Hi, this is the Lucero group at Sac State. Today I'm going to show you how to run a carbonylation reaction. This carbonylation reaction we're going to use to access linoleic acids A, J, D, and B because they're all 3 butanoic acid derivatives. Specifically, this reaction utilizes xanthos, a bidentate ligand, to convert allylic alcohols into linear trans-selective 3 butanoic acid derivatives. We're also going to utilize an in situ generation of CO gas in the form of formic acid. And today I'm just going to show you guys how to set up the reaction because it's a super important one for us here at the Lucero group. Okay, the first thing we're going to do is to an oven dried Schlenk tube with a Teflon stir bar and a weighing paper as a cone. We're going to add in our solids. So the solids we're going to add include the ligand and the palladium catalyst. And first I'll add in the ligand. Just like the Heck reaction, I'm going to utilize this weighing paper as a long cone so none of the solids stick to the side. These solids tend to be very sticky. So I'm going to weigh out the ligand, which is xanthos, and we're going to weigh out 2 mole% of the ligand. Again, just like the previous videos we've recorded, you can notice how the technique I'm using to weigh it out by opening both doors. I'm trying to get 28 megs. A little bit too much. Always close the doors to get your true mass. Okay, that's a little better. I'll add this to the Schlenk tube carefully. Okay, the next solid we're going to weigh out is a 0.5 mole% of palladium. And just like the Heck video, the palladium catalyst, since they're sensitive to moisture and air, they're in the desiccators. So today, we're going to use this catalyst, the DBA ligand, and it's a nice black clumpy solid. I need about 11 mgs. Trying to weigh out exactly as close as I can is important for this reaction. I might need a little bit more. And typically I like to weigh a little bit more rather than a little bit less. Because it sticks to the weighing paper a little bit. Okay. And we'll flush this when we're done. So you can carefully add the last solid. Okay. And we're going to seal this guy up. So double check, make sure you have your stir bar in there. And we're going to use this glass stopcock to seal the side arm. Just going to grease it. And I don't want grease in my reaction, so I'm going to carefully insert this in. Try not to expose the inside of the tube to grease too much. And then we'll take this green little clip and it kind of acts like a spring to keep it on there. So what I like to do is give it a quick little tug and make sure it's on there tight. So it looks pretty good. It's on there nice and tight, nice and greased. This reaction needs to be really airtight, so we need to seal the flask up as best we can. Okay. So now that I've added both the ligand and the palladium, I want to get this Schlenk tube under vacuum so my catalyst is no longer in contact with any moisture or air. So with the pump on and with my trap filled with ice, I'm going to make sure this stopcock is closed and then turn this over to vacuum. With this stopcock closed, I'm simply evacuating the tubing. I'll wait a few seconds and then I'll open up the flask to vacuum. Now that my flask is under vacuum, my catalyst is in a better spot and I can start adding in my reagents. Okay, so we got our solids in the Schlenk tube. It's under nitrogen. We also have the allylic alcohol here, about 2.5 millimoles of the alcohol. We're gonna dilute it in dioxane. Dioxane is the solvent of choice right here. It's important to really have dry and air-free dioxane. So I've got a SureSeal bottle with nitrogen going through it. Today we're gonna use 5 mils of dioxane. So right now, I'm gonna purge out my needle by just sucking up some nitrogen and expelling out into the hood. I'll do that twice. It's important to keep air-free technique. And I need 5 mils of dioxane for this reaction. I'm gonna get about 4 mils right now, and it'll be obvious why I only get 4 mils. in a second. I'm going to use the remaining 1 ml to just wash out my flask. Okay, so I got 4 mils of the dioxane, and I'll dissolve my allylic alcohol in the dioxane. I'm going to give it a really good shake, make sure it all dissolves. And just a reminder, I still need to add 1 more ml of dioxane, but first I'm going to transfer this to the reaction tube. So I have a cannula needle, the same as the last video. The cannula is a double tip needle used to syringe in just reagents and large volume of sensitive reagents. So just like before, I'm going to poke it through and let nitrogen purge out the left side. So what's happening is nitrogen is coming through this tap, which we have labeled green here, coming all the way through and then up out the cannula needle. So I'm just flushing out any air that might be in the needle, and then I'll stab it through into the reaction tube. It's very important at this point that the cannula needle is not below the liquid line. I'm keeping it in the headspace of the flask. And then I'm gonna use an exit needle. Turn up the nitrogen a little bit. And it's very important that you need to turn off the tube from nitrogen. So let's follow the nitrogen flow. It's coming through the green tubing right here, through the cannula needle, and out this exit needle. The exit needle helps keep one-way flow of nitrogen, and we're literally going to use nitrogen pressure to get this alcohol into the tube. So now I can dip the cannula below the liquid level, and I'm going to turn up the nitrogen a little bit, and you'll see it start dripping over into the Schlenk tube. I like using the cannula technique because it makes sure that you get all of your material, in this case the alcohol, transferred. So as I mentioned before, I still have 1 more ml of dioxane to wash out my flask. And I will get that now. Now I've added all of my solvent that I need. And just like before, I'm gonna try to rinse this out so I can transfer all of the material. Again, I'll lower the cannula needle and transfer the last of the reagent. If you find that your material is your liquid's not being transferring, you might just try to turn up the nitrogen pressure or double check your setup. Maybe something's wrong. Maybe you forgot an exit needle or you forgot to turn your stopcock. Okay, now that the solvent and the substrate is added, we're gonna add in our formic acid and then the acetic anhydride. So now we've cannula transferred the alcohol substrate and dioxane into the Schlenk tube. The first or the next reagent we're gonna add is formic acid. Formic acid in this case is serving as the CO source. You can see I have it hooked up with a nitrogen inlet to make sure I really don't introduce any air into my system. So just like before, I'm gonna flush out my needle twice, and I can just do that from the Schlenk tube to make it easy on me. And I need 273 microliters. So I'm going to use a baby syringe and get 273. Get as close as I can. Pull some nitrogen into the syringe and then transfer it. Now I'm going to try to add this in dropwise, and I want to make sure that since it's such a small amount, I'm going to try to drip it in so it doesn't go down the side of the walls. Nice and slowly, just like that. Okay, the first reagent is in. You can notice that there's some extra formic acid that I need to get rid of. I don't want to add this to my reaction. That's just the dead space in the needle. And the next reagent we will add, and the last reagent, is the acetic anhydride. So we've just added formic acid, which is the CO source, and now we're gonna add the activator, which helps release the CO gas, with acetic anhydride. Just like formic acid, we have this hooked up to nitrogen. I'm gonna demonstrate just how to flush out this bottle, take an exit needle, insert it for about 10 seconds, just to clear the headspace of the bottle. Especially with big bottles, old bottles, you want to clear out the headspace with nitrogen, and it's really quick. just like before, I'm gonna flush out my syringe twice with nitrogen. And I'm gonna come back over and grab my acetic anhydride. I need 684 microliters. Actually need a little bit more. Perfect. Okay. Pull a little bit of nitrogen in the headspace to give me a buffer for transfer. And just like the formic acid, I'm gonna drip this in and try not to let it touch any of the walls. This acetic anhydride is the last reagent that we need to add. And the next thing we will do is seal it up the tube really, really tight so the CO gas does not escape. Okay? All good. So before we start to heat this reaction, which is gonna produce the CO gas in situ, we need to seal the Schlenk tube really, really tight. I have a stopper right here, which we're gonna use to seal it up. So I'm gonna turn up the nitrogen flow a little bit and quickly replace the septa with the stopper. I'm gonna grease it really fast so it's nice and tight. And you'll see, you'll hear the air, the nitrogen come out. I'm gonna try to swap this as fast as I can. And turn it down a little bit. So I got my grease stopper here. You can hear that nitrogen roaring out. I'm just trying to grease the top of this Schlenk tube. It's very important to seal it up because the CO gas needs to stay in there. So I've got a few rubber bands. Which I'm going to leverage to seal this up. And it is a little bit sloppy, but you get the hang of it. The rubber bands are really good. They're better than just putting a plastics ket clip on the top of it, because the ket clips, if there's any give or fluctuations in pressure, the ket clips will break, where the rubber bands are stretchy and they're able to have some resistance. So I like to use rubber bands instead of a plastic ket clip, which will break. So I've got 3 rubber bands on there. And because I am very, very picky and paranoid, I like to put a ket clip on top of the rubber bands. And now I'm really, really sealed up. So very, very important. I'm gonna turn the stopcock. And now I'm sealed up. I can turn off nitrogen, turn off all nitrogen gas. And now I feel comfortable in heating up the reaction. So I'll grab an oil bath. This reaction is run for 12 hours at 80 degrees Celsius. And I'll make sure to put the probe in. And since we are sealing up the Schlenk tube at high pressure and high temperature, for safety precautions, we put the shield in place whenever we heat up or cool down the reaction. And so if we look at the ICA plate, I demonstrated in the HEC video how to set this up. It's at 80 degrees Celsius for 12 hours. And I'm just gonna get that started by turning on the temperature and turning on the timer. And this will heat up to 80 degrees, and we're gonna cut back in when it warms up and show you guys what the CO gas looks like.
As you can see, the reaction is now hitting 70 degrees. And if we look in the center of the flask, we'll see mild CO bubbles forming at this point, collecting in the center there. And as we reach closer to 80 degrees, we'll see more and more vigorous bubbling and CO formation.